Today I thought I would show you an alternate to the open loop tuning. Now you might recall that when we did the open loop Ziegler-Nichols tuning, we had to go and get the value of n, which was in percent per minute, and it meant that we had to go and draw a graph with lots and lots of lines across it. In this case, it gets a lot easier because you're just going to go and get the dead time and the time constant, and that should get us to exactly where we need to be. So I'm going to go and open up my simulator, and if I go and get my simulator, we do exactly the same steps. Put the controller into manual, take the output to a known value. I'm going to take mine to 20%. And wait for it to go and settle down. And you can go and see that with an output of 20%, my process variable is going to go to 32.5. Great. Then what we're going to go and do is give it a step change. Not too big. I'm going to go and do about a change up to 50%. So let's go and change it to 50%. There. And wait for the process to self-regulate, which 90% of our processes will do. This, by the way, will not work on an integrating process. It looks like my process variable is going up to about 77.5. So I'm going to go and pause the screen right over there. And now we can go and capture it using the best tool from Microsoft, which is the snipping tool. Great, that's my image that has been captured. And all that I now need to go and do is paste it down. So let's go and do that. We're going to go and paste it in the center of the screen. Now, in this case, there is a variation in the formulas. Again, you would go and decide what process you'd like to go and work with. If I'm working with a nice simple pressure or level loop in which I don't mind an offset, then I only need to go and calculate the gain value. If I'm going to be working with, for example, a flow process or a faster process in which I need to have the gain and the integral, then that would be the formula that I would go and calculate. And if I'm going to go for a full PID control, such as a slow process, then I need to calculate the gain, the integral, and the derivative. Now, as far as these formula are concerned, the gain of the process would be one of the more important ones, and that's really just going to be the change in the process variable divided by the change in the output that would have gone and caused that. TD is my dead time, the time that elapses from when the output is changed until I can see a noticeable change in the process variable. The other one that you might go and see over there is tau. Now, easy enough, just remember that tau is going to be the time constant, the time taken for the process variable to move to 63.2% of where it's going. For me, 63.2% is close to 66%, which is 2/3 of the way. And so that's what we're going to go and do. Now, we're going to use the bottom set of formulas, and again, don't work harder, work smarter. Go and put it inside a spreadsheet and it will go and do all of the calculations for you. So let's bring up my simulator, which was that one that we had, and then we went and captured the image right over there. I'd like to go and write down the values that we had gone and captured. There was a change in the output and there was a change in the process variable. I took the output from 20 to 50%, which is actually a change of 50 minus 20 or 30%. The output went from 32.5% up to 77.5%. The difference between those two is going to be 45%. What else can I pick up from my sketch over here? The dead time is the time that elapses from when the output changed until there's a noticeable change in the process variable. So my output changed about over there. A noticeable change in the process variable, no rocket science over here, probably going to be that value that you can see. So that is going to become my dead time. And in this case, with a scale of 5 minutes for every green block from left to right, maybe that's going to be about 2.5 minutes, and we're happy with that. I'm going to change across to a red pen. The time constant is the time that elapses from when the process variable started to change until it gets to about 2/3 of the way. In other words, that's my dead time that we can see between those 2 points. So my dead time is probably going to be 5 minutes plus 2 plus 3. Maybe going to have 5, 6, 7, 8, 9, 10. Maybe it's going to have a value of about 10 minutes. Okay, totally up to you. Near enough is good enough. Very thumbs up value. It looks like we're going to go and work with those values. So I'm going to go and write this down now. My dead time is going to be about 2.5 minutes, and my time constant, it looks like it's going to be about 5 plus 2 plus. So let's go make it about 10 minutes. That seems to be good for me. Right. Go back to the spreadsheet that I have gone and created and put the value into it. My dead time was about 2.5 minutes. The time constant, or the tower value we got, is about 10 minutes. And then the change in the output. Well, my output changed from 20 to 50%, which was a 30% change. And the process variable changed from 32.5 to 77.5, which was a 45% change. And that's it. It will then go and work out the values for us. We're going to use the PID option. And so I'm going to quickly go and write that down, which is going to be 3.2, 5, and 1.25. Great. Go back to your process and put in the tuning parameters of 3.2 and 5 and 1.25. Put the process into automatic, run the process, and let's go and see what it is going to do now. As always, Ziegler-Nichols is a very aggressive tuning regime, and when it works well, which is like right now. If we go and change the set point, we should find that it gives us great stability and great robustness. If it is oscillating, you might just want to go and fine-tune it using your experience of PID. And my quick suggestion always is just half the gain and twice the integral if you really need to, if it oscillates too badly. But I think we've got a very good process that is working at this point in time. So I'm going to go and pause that and take this off the screen, and we can now go and wrap up this presentation. As always, it has been an absolute pleasure to spend a couple of minutes with you. At the bottom of the screen, you can see my website where you can find many of the courses that I do present around the world. Okay, I will see you with the next recording after this.